Today we are going to discuss about semiconductors for class 12. So here you see that there are three types of substance. One is metal, and another is semiconductors, and third is the insulators. So here you see that metals, we already know that it has low resistivity and high conductivity, whereas insulators, it has high resistivity and low conductivity. But your semiconductors is in between these metals and insulators. Now we know about the metals, how it conducts electricity. That is, metals, it can conduct electricity. How? Because we know that it has free electrons, and where does these free electrons lie? They lie on the surface of the metal, and when a potential difference is applied, the flow of the electrons takes place, and that is the flow of the current takes place. But in case of insulator, we know that there is no free electrons, so there is no flow of the current. But about semiconductors, it also conducts electricity. There is conduction. But how is it possible? So here comes our explanation. That is, a semiconductor, we know that in a crystal, electrons has a unique position. So it has a unique position, it has a unique energy level. It has a unique energy level. And we know that two electrons, they can't have the same quantum numbers. We know that. So two electrons, they will have different energy levels. Due to these continuous variations of these energy levels, remember that, due to the continuous variations of this energy level, energy bands are created. Remember that. This is very important. That is, in a crystal, electron has a unique position, so it has a unique energy level. And due to the continuous variations of this energy levels, due to the continuous variations of these energy levels, there is a energy band is created. Now, as we have already studied, that when an external energy is applied, the electrons, it moves to a higher orbit. It moves to a higher orbit. We have already studied about it. So here comes the fact. The electrons, the valence electrons, here the valence electrons are responsible for conduction. So what happens? The valence electrons, when an external energy is supplied, then the valence electrons, it moves to a higher energy level. So this higher energy level is the conduction band, and the valence electrons present, this is called the valency band. And when an external energy is applied, it moves to a higher energy level, that is the conduction band. And this valency band and the conduction band, there may be an energy gap, or they may overlap. But remember this, all these things is happening in the crystal itself. So here, that means here semiconductors, the conduction is possible because of the presence of electron in the conduction band, because it is free from the attractive force of the nucleus. So here, this is how, and at the same time you will find that there is a hole created in the valence band. So again, the electron, nearest electron from the valence band will move to occupy that hole, and it will create a new hole. So here two types of conduction is possible. One is due to the due to the electron present in the conduction band, and other is due to the electron present in the valency band. That is, the electron present in the conduction band, because of this conduction is possible, and in the valency band because of the movement of the holes. Because when the electron moves from the valence band to the to the conduction band, there is a hole is created, and the electron from the nearest valence band will move to the hole, creating a new hole. So two types of conduction is possible. So it has been made clear that in semiconductors how conduction is possible. It has given an example in your textbook. It has given an example. Actually, for semiconductors we use silicon and germanium, and in silicon or germanium their valence electrons is 4. For silicon it is 2s2, 2p6, 2p4. So here you find that it has 4 electrons in the outermost shell. So here your configuration is the electronic configuration, that is 2s2, 2p4. But let us take that there are n numbers of silicon atoms. So you have 4n numbers of valence electrons. But in this configuration, that is 2s2, 2p, in 2s and 2p, we have the capacity of 2s2, 2p6. That means we have how much? Here we have 8 electrons. Here we have 8 electrons. It has the capacity of 8 electrons. That means 8n number of electrons it has the capacity. So this 8n has been divided into 2 bands. 4n it is a 2 half. So first it has been divided in 2 half. One half is the valence band and another half is the conduction band. So here you see how the conduction band is created. So it has been stepwise, it has been explained for you that the variations in energy levels, it creates an energy band, and this variation is energy level because an electron has a unique position in a crystal, so it has a unique energy level. So no two electrons can have the same energy level. So because of the variations of the energy level, the energy band is created, and the electrons present in the valence electron, it creates the valency band, and the next higher is the conduction band. When an external energy is supplied, then the electrons moves from the valence band to the conduction band, and so here two type of conduction is possible. One is due to the electron present in the conduction band, and another because of the hole created in the valence band, that is the nearest electron in the valence band will move to the hole and it will create a new hole. Similarly, the movement of the hole as well in the valence band and the movement of the electron in the conduction band is possible. So here there are two types of conduction is possible. Now how again it has explained to you that how conduction band is created. So here you see how conduction band is created. It has given an example. Mostly semiconductors we take silicon or germanium, but in both silicon and germanium it has outermost 4 numbers of electrons. For silicon it is 2s2, 2p4. So here we have, if we have 8 n numbers of electrons, we have 4 n numbers of valence electrons. But in this configuration you see that it has the capacity of 2s2, 2p6. It has the capacity of 8 electrons. So if there are n number of silicon atoms, so we have 8 n numbers of possible electrons. So these 8 n numbers of electrons, it has been divided into 2 groups. Two groups it is divided into, one is the valence band, another is the conduction band. So here it has been explained to you that how conduction band is created, and in the conduction band it has been divided into parts. So here in the conduction band there is no electron at present. So this is how they try to explain to you how this conduction band is created. Now the next topic is here about there are two types of semiconductors. One is the intrinsic semiconductor, another is the extrinsic semiconductor. So here, how intrinsic semiconductors are made. So in this intrinsic semiconductors, here what happens, that is when an external energy is supplied, then the electrons moves from the valence band to the conduction band, and in this way electrons present in the conduction band as well as the hole created in the valence band, due to the hole created in the valence band, electron in the nearest by electron moves to the hole and it creates a new hole, and in this way two types of conduction is possible in intrinsic semiconductors. So here again it has been given a differences, that is in metals there are possibility that the overlap of the conduction band and the valence band takes place. How overlap? That means if the lower level of the conduction band, is lower than the higher level of the valency band, then the overlap is possible. So here electrons are easily available in conduction band. So here again conduction is possible. This happens in many cases of metal. But in case of insulators, what happens, that is the energy gap between the valency band and the conduction band is greater than 3 electron volts. So any time the conduction band is empty, so the conduction is not at all possible in insulators. But in semiconductors, this energy gap is below 3 electron volt and the conduction is possible. Now we have learned about the intrinsic semiconductors. So now it is the simple semiconductor, intrinsic semiconductors, it is simple. So here extrinsic semiconductor, it is the main part of the semiconductors. Here what happens, we do two types of methods are possible. That is we take a silicon crystal, and every silicon atom forms covalent bond with the nearest 4 silicon atoms. It is a tetravalent and its structure is it is a tetravalent. So here each silicon atom forms bond with the nearest 4 silicon atom. So now if there are two ways, if we remove a silicon atom and place another atom of valency 5, pentavalent, by this method, this is one method, and another method, if you remove a silicon atom and place a trivalent atom, both these two ways are possible. So now this extrinsic semiconductors has been divided into 2 sections. One is the N-type semiconductors and other is the P-type semiconductors. In N-type semiconductors, what is done actually? In N-type semiconductors, what is done? That is, a silicon atom is removed and a pentavalent atom is placed there. So 4 of its electrons will form bond with its nearest 4 silicon atom, and one electron will remain free. 4 of its electrons will form covalent bond with the nearest 4 silicon atom, and the 1 electron, it will remain free any time, and so the conduction is possible. What happens at that step? While this is called doping. At the time of doping, but at the time of doping, it is these electrons is independent of the temperature or the heat given to you. So in this process, what happens, as to form a doping, say an external energy is required. So when there an external energy is required, there is the silicon atoms gains energy, and at the same time, some of the electrons, some of the bonds gets broken up and electrons are released. So what happens here, No doubt, it has given you here it has been given an example that for silicon the energy gap between the valency band and the conduction band for silicon is most probably 0.5 electron volt. But here below this electron volt in the valency band, the while doping, when the doping takes place, when an external, that means an external energy is given, at that time some of these electrons, the bonds breaks up and electrons gets released and holes are created. So what happens that when the finally n-type semiconductors are formed, what happens that some of the holes remains there. So in n types of semiconductors, two things happen. One is due to doping, there are free electrons, and because external heat is supplied, external energy is supplied for doping, that external energy leads to intrinsic semiconductor in the same semiconductor, and holes are created. So that means when the final semiconductors are being formed, that means the temperature is slowly reduced. At that time electrons moves to the holes. In that it starts moving to the holes, and in this process, when the complete your semiconductor is n-type semiconductor is formed, some of the holes remains there, and also the free electrons also remains there. So when an n-type semiconductors are formed, here what do we get at the final stage? We get the free electrons, and this is caused due to doping, and some of the holes which is caused due to intrinsic effect. So here we get two types, that is, one, we get electrons also as well as we get holes also. But the majority charge carrier are the electrons and the minority charge carrier the hole, because the hole is created due to intrinsic effect and the electrons are created due to doping. So this is the case. Similarly, in p-type semiconductors, what happens in p-type semiconductors? We remove a silicon atom and place a trivalent. So here the three of its electrons will form bond with the nearest silicon atom, and one of the bond electrons will remain vacant, that is, the hole is created. So from the nearest electron will move to that hole and create a new hole. So similarly, holes are created. Again, the same effect here also, because here external energy is supplied for doping, and at that time intrinsic effect takes place. Some of the bonds in the valence band it breaks, and this electrons are released, and at the time of final formation of the p-type semiconductors, what happens? The majority charge carrier are the holes and the minority charge carriers are the electrons. This is the result which happens in the p-type semiconductors. So this is how your n-type semiconductors and p-type semiconductors is formed. So remember that in p-type semiconductors, the majority charge carriers are electrons which is created due to doping, and minority charge carriers are the holes because of the intrinsic effect. And in the extrinsic semiconductors, the majority charge carriers are the holes, and the minority holes which is created due to doping, and the minority charge carriers are the electrons which is due to the intrinsic effect. So this is how this n-type and p-type semiconductors are formed. Now let us move to the p-n junction. So what happens in the p-n junction? See, in this p-n junction, this is very important. In this p-n junction, in this p-n junction, what happens? We know that the p semiconductors, here there is majority charge carriers are the holes, and your N is the majority charge carrier is your electrons. So due to concentration difference, what happens? Due to concentration difference, the electrons from the N side moves to the hole P side, and the holes from the P side move to the N side. So here, in these two ways, conduction is possible, and this is called as diffusion current, and this is called as diffusion current. So now what happens at the same time when the electrons moves from your N type to the P type, when it moves from the N type semiconductor to the P type, so at the edge there is a plus charge is created because of the deficiency of electrons, that is a plus charge is created, and these are immobile charges. And similarly, what happens on the P type due to the movement of the holes from P type to the N type on the edge of this P type, that is negative charge is created. So here, due to the positive charge on the edge created on the N type and the negative charge created on the edge of the P type, that is there is an electric field is created. Because of this electric field, the minority charge carrier starts to move. Because of this electric field, the minority charge carrier starts to move. That is the minority charge carrier in N type is the hole, and the minority charge carrier in the P type is the electron. It starts to move, and due to this movement, a drift current is possible. So here, the direction of the drift current is opposite to the diffusion current, and this when the diffusion current is equal to the drift current, your PN junction is formed, which is a diode. Your PN junction is formed. So this is how a PN junction is created. This is what I have told you, what it has been explained in your textbook. Now here comes our forward bias and the reverse bias. So in the forward bias, what happens? The P type is connected to the positive terminal of the battery, and the N type is connected to the negative terminal of the battery. So when the potential difference is applied, there is a depletion region, that is where the electric field is created. That region is the depletion region. Where the electric field is created, that region is the depletion region. Your depletion region decreases, your barrier potential also decreases. And due to decrease in the depletion region and the barrier potential, what happens? The hole, it moves through the depletion region to the end of the N type semiconductor, and electron from the N type semiconductor moves to the end of the P type semiconductor, and here you see that is the conduction is possible, but the current flow is very slow. So this is forward bias. So remember, when for external potential difference is applied in a PN junction, your depletion region decreases, where the electric field is produced, and that is also called the barrier potential. That barrier potential also decreases. Now in case of reverse bias, what happens? In case of reverse bias, what happens? That is the P type is connected to the negative terminal of the battery, and the N type is connected to the positive terminal of the battery. So here what happens? Your depletion region increases, your barrier potential increases, and here the flow of the current is not possible. So in the reverse bias, your flow of the current is not possible. So in the forward bias, your flow of the current is possible, but in the reverse bias your flow of the current is not possible. Now, so we use this PN junction, that is the diode, we use it as a rectifier. Rectifier, that means it can convert the AC into DC. It can convert the AC into DC. So here two diodes are used. That means for the positive half of the AC current, because we know that it is a sinusoidal wave. So for positive half of the cycle, that is the one diode, it act as a forward bias, and for positive half there are two diodes are taken. So it has been in the circuit, so it has been arranged in such a way for the positive half of the cycle, that is cycle which of the AC current, one diode acts as a forward bias and the other diode acts, for that cycle it acts as a reverse. Again for the second half of that is negative half of the cycle, the second diode, it acts as a forward bias for the negative half of the cycle, and the first diode, it acts as the reverse bias for the negative half of the cycle. So in this way we find that the two diodes makes both the half of the cycle to move. It makes both the half of the cycle it helps to flow of the current. That means what happens, that is there are two diodes are taken for the positive half of the cycle. Let us take two diodes and we name it first and the second. For the first diode, the positive half of the cycle act as a forward bias, and your second diode act as a reverse bias. So it will so your positive cycle will move forward, and for the negative half of the cycle, the second diode will act as a forward bias and your first diode will act as a reverse bias. So your second half is again made possible to move forward. So in this way the AC current is converted into DC current. In this way the AC current is converted into DC current. So this is how rectification is done. So this is all about the semiconductors, which is given in your textbook according to your syllabus, and I have tried to explain you in a simple manner so that you can understand it.